today you're going to be solving systems of equations using elimination. So we've already done graphing and substitution. So today we're going to use elimination, and it is exactly as it sounds. You're eliminating one of the variables. So the goal is, if we work through this example, is to line up your variables so that they're directly with each other, on top of each other. And you're going to find the sum of your equations so that they cancel out. So in this case, we have a negative y and a positive y that will then cancel out. And when I add the two equations together, I've got just x alone. So I can solve for x. Then you would plug back in to get the second one. So let's work through these people together. So 3y equals 24 minus 6x, and 4x equals 18 minus 3y. So as we can tell, the variables are not lined up. I've got x and y over each other, and our constants are lined up, but we need to manipulate a little bit just to get that together. So if I take this equation and I add 6x to the other side, I've got 6x plus 3y equals 24. And then I can take this equation and move 3y to the other side. So I've got 4x plus 3y equals 18. So now we're going to line up our equations because now I've got them both in standard form, so they should line up. So let's pull this one over. 6x plus 3y equals 24. So if the goal is to eliminate, you need to check the signs. So here I've got two positives, and here I've got two positives. So right there, nothing's going to eliminate, but I do have 3's on both y's. So if I can just make one of them negative, they'll cancel out. So let's go ahead and just multiply our top equation by negative 1, because that will make negative 3y. But it changes everything, so we need to remember to change everything in our equation. So we've got negative 4x. Here, let's write it over here. Negative 4x minus 3y equals negative 18, right? And since I did not change the second equation, let's just pull it on over. 6x plus 3y equals 24. So now I can combine my equations to eliminate that variable. So take a second, think about which variable it's going to eliminate. Okay, so 3 is going to eliminate, so 3 is gone. When I combine negative 4x and 6x, I have 2x, and when I combine negative 18 and 24, I have 6. So now I can solve for x. If I divide both sides by 2, I've got x equals 3. But remember, you're not done until you have both variables. So go all the way back to the beginning. If x is 3, I need to plug it back in to find y. So let's use our first equation. 3y equals 24 minus 6 times what we now know is 3. So 3y equals 24 minus 18.
Please release all bus riders to the bus ramp at this time. Please release all bus riders to the bus ramp at this time, please.
Okay. So obviously no bus riders are being released right now, but let's just continue. 24 minus 18 would give us 6. 3y equals 6. So y is 2. So your solution is 3, 2. So a lot of work, but we got there. Okay, let's flip over to the back of that front page. And let's do one more together. So number 1 is set up with our variables already in line. So take a second, pause the video, and decide with your table group, do I need to manipulate anything in order to eliminate a variable? Okay, so you should have decided that you don't need to manipulate anything because y is already set to eliminate. So when I combine my other terms, I've got 6x equals 54. So that means that x is 9. So go back. 2 times 9 minus 3y equals 12. So 18. Subtract 18. And I will divide both sides by -3. Y is 2. So your solution is 9, 2. Okay, pause the video and work number 2, and then we'll check. Okay, you should have gotten 1, -4. Take a second to check your work, and if you made a mistake, go ahead and figure out where that is and make that edit. Okay. So the only thing we've had to multiply by so far is -1, just to change some signs. But sometimes we might want to just manipulate the entire equation by something more than -1. So looking at this first example, while your steps remain the same, you're going to add a step where you multiply your equations to make sure that one of your variables can cancel out. So these equations are almost set up for substitution, and if you really wanted to, you could use substitution, but elimination is typically a faster way to solve. And since I already have my variables lined up, there's possibly a way that I could eliminate. So I could either eliminate x, or I could eliminate y, either way. So let's eliminate x first. So if I want to eliminate x, I'll do x in blue, and then we can go back and I'll show you how to eliminate y, because either way would work. So if I eliminate x, I'm going to have to multiply that top equation, because how do I get from 2 to 4 and then make it the opposite? So times -2. So that'll eliminate it will eliminate out. So I'm going to pull this one over here. 4x plus 3y equals 18. And then if I multiply this top one by -2, I get -4x minus 2y equals and -16. Okay, so you've got everything lined up, and you should at this point recognize that x is going to eliminate. So I eliminate x, which leaves me with y equals 2. So it was pretty fast, right? So if y equals 2, I'll plug that back in. 2x plus 2 equals 8. So 2x equals 6. X is 3. So your solution, I guess I should have been using all this space, right? X is 3. Y is 2. So I have 3, 2. Now what if I would have used the other variable? So I'm going to erase, and I'm going to use a different color. So if you've already used all that space, look, we've saved all of this down here that we can use. So if I want to eliminate y, how can I get both of these as equal opposites? I can multiply my top equation by -3, right? So let's use this space this time. We're going to multiply by -3. So 2x plus y equals 8. Let's multiply it by -3. So we get -6x minus 3y equals -24. I don't need to do anything to my other equation because if I line it up, which variable will eliminate? You should all be saying y. Okay, so I do that and I'm left with -2x equals -6, which will give me 3 again. And if I plug that in, I should get 2 again. So you can manipulate a bunch of different ways. Alright, so let's move on. I'm going to do number 1. I'm going to start you off on number 1, and then you guys have to finish it. So if I look at number 1, I'm looking, do I eliminate x or do I eliminate y? And you've got 1x and 4x, or you've got 3y and 2y. So think about the easiest route here. If you've got a 1 and a 4, the easiest route is going to be times -4 on that top. So that when you line it up, -4x minus 12y equals -40, you can then eliminate that x. Okay, so you go ahead and finish that one on your own. Pause the video, work through to finish 1, 2, 3, and 4, and then we'll talk about some special cases. Okay, go ahead and check your answers. Your process is up there too. So go ahead, if you made a mistake somewhere along the line, go ahead and check it. Okay, so y'all probably know what's coming with special cases because they're the same special cases that we had before. If I have 2x plus 3y equals 9 and 2x plus 3y equals 5, if I isolate the variables, multiply by -1, -2x minus 3y equals -9. Well, cancel, cancel, and -4. So 0 equals -4. Everybody should be able to tell me what that means. No solution. Okay. Situation 2 is lined up perfectly, but cancel, cancel, cancel. So what are you left with on the left-hand side? 0 equals 0. True statement. Infinite. Okay, so now remember you can always go back and throw all these into your graph to double check your answer. Okay, so if the outcome is true, infinite. If it is false, no solution. Okay? So here is your homework. Please have it ready to check on Monday. Have a great afternoon.